Hello, welcome back to the channel. This is a talk which I gave to my computer science society, but I thought I would reshare here on the channel. This is a talk about macro metaprogramming and why it's awesome, up until the point where it's not. So, without anything further ado, let's get started. So what is all of this? It's something you can do with the C preprocessor, which is a glorified copy-paste tool, essentially. And it exists because the original C standard, C89, did not have any constants, and you would probably want to define constants. And another reason would be probably Dennis Ritchie, the creator of C. He essentially wanted to see the world burn. Anyways, enough of this punny stuff. What can I do? Let's say we want to define a constant. So the way you do is just define it. You type in hashtag define, the name of the constant, and give it some value. Then you just use it, and right here you can see we have two print statements. One is for B emoji and the other is for pi. And once you use them, the compiler will take a step behind the scenes to replace these places, these constants, with actual values of them. So you can actually trigger the pre-processing step by passing through the -e command to the compiler, which tells it just do pre-processing, and it will spit out pre-processed code, which right here says massive constant, and it takes the hexadecimal value for the unofficial B emoji Unicode character, and then the pi value, arguably not complete, but not much we can do about. So essentially a constant is just a named literal. It makes things so much more readable. But this talk is about madness that comes with it, so where is it? Well, let's check level 1, parametrized macros. So you've got the regular constant, which is a standard definition with its value, and then, well, a parametrized macro, essentially it takes in a parameter, as the name implies. And right here you can see print num, it takes a parameter x, something, doesn't matter, and it just creates this code line, which is printf, printing number, and it passes through the x. And that is the parameterized macro. The way you use it, you just go ahead and use it regularly. You type in print num, passing 5, you type in print num, passing B emoji, and when you pre-process it, you get the output, where it says printf, printing number 5, printf, printing number, and the B emoji value. As simple as that. And when you run it, you get the output you expect. Simple as that. So this actually is helping things. Another cool thing you can do is stringify values. What do I mean by that? Notice the hashtag right here. It has a print statement which takes actually two format parameters. One is a string and the other is a number. What hashtag x does, it turns what is inside x, what is x, into a string. So you use it the same way, and just to show you what happens after pre-processing, you get the input of the macro created into a string, essentially. So you have the first line printing 5, it creates a string 5, and then 5 as the value. And printing the second line, printing B emoji, as you can see, it doesn't stringify the value of B emoji. Instead, it stringifies the actual constant that goes into the macro. So this is a really clear distinction, and sometimes it may mess your code up. It may make you wonder why some things are working not the way you're intended it to do. So just keep it in mind that stringification stringifies the x, and while after pre-processing you get what's inside of x. So you just compile as usual and run, and you get really nice. Printing 5 and it says 5, printing B emoji and it says the value, the decimal value of the B emoji. It's pretty cool, I think. But we can do even more things, and that would be generating functions. This comes in very handy in game hacking. This example is very much about game hacking. You've got network variables, for instance, in Source Engine. They're called netvars, and they're usually on an object, on individual objects, but right here it's a global map. It has acceleration and it has gravity. They have some values set. We have our good old print num macro, and then we use it. We first print num the acceleration netvar, then we change the netvar to have the value of 12, and then we print it again. I won't show pre-processing, you just run it and you get what you expect. But the thing is that, well, in game hacking, you don't just have access to a STD map which you can easily index. No, you kind of have to access it through some helper functions. And we don't have just straight up access to a netvars map. And also you quite often want to just have a more dedicated accessor, which like feels more like a native function. So the way to do it is have the same code as before. Above this is the map, and we have the same print num. And what we then do is define this macro, which creates a netvar. There's quite a lot in it. Let's unpack it. Netvar takes an x and it returns an integer reference, and it essentially defines a function which is net underscore hashtag x. What this does, that bit, it actually concatenates net underscore with the x, with the name of x. So not the value, but the name, what x is. So it creates a function. For instance, for acceleration it would be net underscore acceleration, for gravity is net underscore gravity. Then it goes into the body and it retrieves the acceleration, for instance, and then it just simply returns it out. As simple as that. Then you just define two netvars, one for acceleration, one for gravity, and then you just use it as usual as actual functions rather than map lookups. So this way, well, you have print acceleration, set acceleration, and then print acceleration again. So just to show you what pre-processed output looks like, you just have these two functions generated for you, and then the code just does what we expect it to do. And when you run it, you get the output you expect. So this has been pretty cool so far, but we can go deeper. What if we made things so readable you have one macro which does everything? Well, meet config system, and by no means this is definitely not something I've written in my life, definitely not. You just have some config variable, you define a macro which has type name, which equals to some default value. And it doesn't matter what the type is, it doesn't matter what the name is, it doesn't matter what the default value is. As long as it compiles, it's fine. And then we can add some future expansions like key bindings or something. Don't worry, we won't get back to it. And then you just use it. You can say config, boolean config for menu open, it's set to false. And then you just use it even further. Like right here, you can see all the options defined. Fun fact, that's from my really old CSGO hack. Also, don't worry, I was only hack versus hacking, it's really good fun. So essentially you have this. Now we need to somehow save the configs and load them up, because this is kind of useless. Why couldn't we just define them as normal variables? Well, you can do something really awesome and create this save config function, which creates a map, calls doConfig serialized s, and then returns the serialized map. And the load function does the same thing, except it calls doConfig serialized l. What is doConfig and why do we pass s and l? Well, doConfig is another macro, which takes in location and type. Location is the serialized and the type is either S or L. And why do we pass S or L? Well, because we actually concatenate the type to another definition, and that forms another macro. So it forms either sconfig or lconfig. And that's actually really, really awesome, I believe. You just have this single line which either should load or save a config, and you just define it for every single variable, and it becomes rather scary. But it's not the scariest part. The sconfig is a simple input it into a string stream and set it. lconfig is outputted from the string stream into the variable, and it's really simple. You use it. You have, first of all, we save it, we print it out, and we load. It's really awesome. And we just compile it, we run it, we see output of different variables which we defined, and then we go, oh, we got a segmentation, well, something crashes. No worries, we will debug it. So we run it in debugger, we will run it till crashes, and we will check the backtrace. As you can see, there is a frame in frame 3 which says in load config, so load config crashes, no problem. Let's check what crashes. It crashes in do config. Just for reference, this is what preprocessed output does. What I mean is it crashes somewhere inside. So macros. What I can say about them, they're really awesome. You will get tempted to use them. And then eventually you'll get grilled like Icarus did. That's about it. That's what I wanted to say with this talk. And one link, there is my talk page on my GitHub repo. And yeah, thank you so much for watching. I hope you enjoyed. This was a talk I gave to my Computer Science Society at University of Birmingham. If you want to see other talks, the link's in the description. There are like some really awesome talks about speedrunning, AI, and CTFs. It's really awesome. Please check it out if you're interested. And yeah, don't forget to overflow the like button. Tell me what you think of this. Maybe it was cool, maybe it wasn't. It's a kind of a different experiment I made, so let me know how it went. And if you want to see more cool stuff, don't forget to hit subscribe button, and I'll guess I'll see you next time. Don't forget, my name was Heap, yours wasn't defined. See ya.